Okay, continuing with error measurement and uncertainty propagation in your measurements. All right. All right, last we looked at if we quantified our sig fig. So we took a measurement. All measurements are going to have significant figures, which are going to be the significant numbers in your measurement. Tell how precise or accurate your measuring device is. All the numbers, again, are important. However, some of them are going to either be significant or not. But now let's go and report the level of accuracy that we would have. So again, as stated in the first lecture, this is going to be somewhat of a simplification, but it is probably an extension from what you learned in physics or chemistry or other science classes. All right. Again, this is a simplification from a full statistical analysis. Okay, as talked about a couple lectures ago when you measure the density of some household liquids, the goal was to take 3 measurements and take the average. So the first step is to take the 3 measurements and record them, and then calculate the average. Again, beware the following is a simplified process. Okay, so what you do is you take the measured value. And then plus or minus the uncertainty, and then put the proper units. Okay, so you measure, the scale says 10.1. What is going to be the, put down that measured value of 10.1, the uncertainty is going to be, in your particular measurement, is going to be the last digit of your scale or your estimation. The uncertainty or your estimation. We'll go over what this means. So when you read a scale and it says 10.001, the scale is estimating that 0.1. So what this is going to be, we'll let W stand for the measured value, plus or minus delta W. And this again is your uncertainty. This is your measured value. Additionally, one way that this also can be quantified is percent uncertainty. Which is W plus or minus delta W. So we can have delta W over W times by 100, which is going to be your percent uncertainty. All right, let's go over some example problems. So, if you put something on a scale, you read the digital readout, and again, if the digital readout is 10.005, this last digit is the uncertain digit. This would be written as 10.005 plus or minus 0.001. You'll have a plus or minus 0.001 in the uncertainty. This would be your W value, and this is your delta W value. So all the scales are going to estimate the last digit. Okay, if you are actually estimating a particular measuring device besides an electronic scale, if let's say you have a ruler. So let's say this will be a broken edge of a material, and then let's say we have it's going to continue out in this direction, and then here's, let's say, your measuring device. Or if this is going to be 5 units, let's say that this is 6 units. Let's say you're going to have that on the scale. So you could say, all right, that's 5, that's 6. You know it's greater than 5, and you know it's less than 6. So what is it going to be? Well, I would estimate that would be about 5.5. So I would estimate this length to be, given by this one, as 5.4 plus or minus 0.1. That's going to be 1. You estimate 1 better than what's going to be on the device. Well, let's say your scale is a little bit better. Let's say you have 0.1 marks. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 to the 0 point. Now we can come up with an estimate. We know it's 5.1, 2, 3, 4, and it's a little bit better than that. So this would be 5.4, and it's about, I would say it's about 0.2 from there. 5.42 plus or minus 0.01. Because you're estimating 1 digit or 1 unit better. All right. Now let's go, and if we had a few measurements. So that's how you would have your results if you were measuring something on each one of these 6, and each progressive, if you have more dashes, you'll get another level of additional number of sig figs. Alright, so now if you took some measurements, and let's say your first measurement was 11.1, and then 11.3, and then 10.9. To come up with the average, you add up the 3 of them. And in this case, it comes up to be 33.3. And then you divide by the number of them, which is 3, and then your average value would be 11.1 plus or minus 0.1. That's going to be your point of estimation that you would have. Let's do an example with the percent uncertainty. Let's say you took a measurement of 5.5 plus or minus 0.1. Delta W over W times 100, in this case, is going to be 0.1 divided by 5.5 times 100, gets you a value of 1.8%. if you had took a measurement of 5.45 plus or minus 0.01, your percent, delta W over W times 100, again would be the 0.01 over 5.45, and then rounding up to the second digit, you would get 0.18%. That's the way you can come up with your number of sig figs. 2 sig figs, 3 sig figs. And then you estimate that last digit. That's what it's going to be implied when we record your results. Alright, so we had gone over sig fig calculations on measurements. Addition, subtraction, multiplication, and division. But now what do we need to do for our uncertainty term? When you do these multiplications, divisions, additions, subtractions, what are going to be the processes to record your uncertainty? Alright, so the uncertainty propagation. The first is going to be, and we'll work through an example of this. If you have W plus or minus delta W, that's one measurement. And then you add it to P plus or minus delta P. That's another measurement, but you have to add them together. Let's come up with some values of what P and W are going to be. So we'll define W plus or minus delta W as 3.04 plus or minus 0.001. 0.01, I should say. And then P plus or minus delta P as 1.03 plus or minus 0.01.